Hi friends, good evening. This is Tulsi Bisain, and today we will continue our previous topic, cost function. So today I am going to start with what is the cost function and what are the different types and what is the importance of cost function in machine learning and deep learning. So let's get started. So in previous sessions, we have seen about the loss functions and what is the relation between the loss function and the activation function. So now we will see what is the cost function. So you know that the loss function and the cost function are very much similar to each other, but there is a minor difference between them. That cost function is also used to calculate the error, but in cost function we are summing up all the loss functions. Means for one training set, if you are calculating the error between the predicted value and the actual value, it is called loss function. But when the same process we are doing for the all of the training set, then it is called as the cost function. Means for one training set only, it will be loss function, and for whole model or all the data, it will called a cost function. So cost function gives us the value which shows us that how our prediction is going in the wrong direction. Means if we are getting the high value of the cost function or the loss function, it means we are going into the wrong direction. Means we are not getting the actual prediction of the output. Okay, and here you can see the formula for calculating the error function. So it is also called error function. So here you can see half y minus y hat square. Okay, it can be y hat minus y also. So this is the actual value and the predicted value. So this is the difference and square. And here, if we are considering this only, half y minus y hat square, that will be a loss function. But when we are summing up for 1 to m r means these are our 1 to m training sets, means all training sets. So it will be a cost function. So here you can see that the inputs are coming from the input nodes and weights. We are using the weights also. Here we are calculating the input and the weights with the bias also. We are adding the bias also, and by using activation functions we are calculating some predicted value, and then we are checking this predicted value with our actual value, and if there is a difference, that will be our error. And then according to that error, we have to adjust our weights and the biases value. So in this way the whole process is repeated until we are getting the near about, means the near actual prediction value. Okay, next is, so this is the difference between the cost function and the loss function. I hope you can understand it properly. These are the various types of the cost function which is used for the regression type of problems. So here you can see that the mean error, mean squared error, mean absolute error, root mean square error, categorical cross entropy cost function, and binary cross entropy cost function. So all this we have already seen in the detail in the loss functions. Just here we are calculating this for our whole data in the cost function. So these are all the types. So we are not going into detail for that. Now we will see, means there are some questions which maybe comes under our mind, that is the cost function is differ in the machine learning or the regression type of problem or the classification type of problem or the neural networks. So if we will see this one by one, is there any difference, or is this a kind of similar thing? But it may be the all the cost functions are the same, means we are calculating the errors only, but when comes to the process it may be differ, or maybe the parameters we are using, they are different. So we will see one by one them. So in machine learning we are we generally doing our regression type of problems, or we are solving a classification type of problem. So in machine learning, we wanted to know that how model is performing. So for getting the accuracy of the model or the model performance, we are taking the we are plotting the values, or we are getting the performance matrices by accuracy value checking, or the performance matrix or the confusion matrix by the F1 score values. So by all using this kind of matrices, we are getting that how our model gives us the accuracy. So in this way also we can get that if our MSC value or the mean square error value, if we are calculating, or the root mean square value if we are calculating, Rn and R2 square. So if that value goes high, means our cost function value is high, means our error rate is high, means our model is not performing well. So that is the one scenario which we can use for getting our uh, performance of the model. So in this way, in machine learning, we are calculating the cost function. Okay. So if you can see the linear regression problem, so there we are finding the best fit line. How can we get that best fit line? By calculating the errors for various data points. So this is the concept regarding the machine learning. Now, is there any function which helps us, the cost function, to minimize its value? So yes, there is a algorithm called gradient descent algorithm that helps the model to get the minimum value of the cost function by using the gradient descent algorithm. So what gradient descent algorithms, we have already seen this, but here is the brief concept about it. So it gives the direction in which, suppose there is a hill and you want to go into the minimum slope value, or the at the bottom of the hill. So what you will do, you will take the slippest side and steepest side, and then we will move in that direction. Okay, so that same thing done by the gradient descent also. It helps us to get the direction in which we are continuation we are continue getting the minimum value of the error. Okay, means in each every step we are getting the less error. You can see here in top we are getting the big errors or the large value of the errors, and then we are slightly reducing the value of the error. So in this way it going to work. Now next is linear regression problem. So linear regression, we are calculating the error between this line and the all the data points. Okay, and now we are getting the average of all the data points error, and we are trying to get the line which gives us the minimum error for all the data set, and that is called the best fit line. So this best fit line is generalized for all the data points, and it is set as that that the all the data points, when we are getting the average for all the data points, we are getting the minimum value of the error. So this is in the case of the linear regression we are doing, and we are calculating that error by root mean square value, and we are trying to minimize that value. Okay, and here also when we are applying the gradient descent, so it will decrease our error constantly. Now in neural networks, so what we are doing in the neural networks, in neural network taking the input from the input nodes, it takes some weights also, it takes some biases also, and based on that the each layer the errors are calculated, and that the errors are back propagated to the previous layer so that the weights can be adjusted. Okay, so the processing of the errors are different, and so you can see here the input 1, input 2, input 3, the algorithm means what, when we are summing all the input and the weights with the biases, we are using the activation functions, then we are calculating the error, no, sorry, means we are getting the predicted value. and then we are compare that value with the whatever is the target prediction, and then we are calculating the error, means the difference between the actual and the predicted value, and then we are trying to reduce that error by back propagating or the other methods. So this is the process of calculating the cost function. Cost function means when one layer we are calculating, that will be error. For all the that will be a loss function or the error. For all the layers or for all the data we are calculating, that will be the cost function. So in each layer, okay, there is a concept of local minima and the global minima. So that I will explain you here, that in each layer we are calculating the error, okay, or the loss function. In each layer we are calculating the gradient descent. In layer 1 we have calculated the gradient descent. We are calculating the gradient descent in the layer 2 also, in layer 3 also, and then we will compare all of that value, and then we will pick the value which is minimum at its level, okay, and that will call the global minima, and that value we will take as the cost function for all the network. Okay, hope you can understand it, you are able to understand it. If this was the concept of the cost function and the loss function, which we have already seen in the previous slides. So how to implement this cost function in the Python? So here for iteration in range 0 to new iteration, 0 means we are calculating, means we are repeating all this process for our whole data. Okay, if you will get any problem, then you can ask. So here first we are calculating the hypothesis is equal to np dot x into theta. Okay, so here hypothesis means the considerations, means first we are creating a np array, numpy array, and then we are doing the dot product of the x means the input and the theta means the weights. Okay, you can see here in the first slide here. This is the process. Okay, here we are creating the dot product of the input and the weight, so that will the same, and that will generate a hypothesis here, because the weights can be adjusted. Okay, so therefore that is a hypothesis means just a consideration. And now we will calculate the loss means whatever the we have calculated minus the actual value. Okay, now we are calculating j means the loss function. So here we will calculate loss function by this formula. Okay, and then cost append means when we are calculating for one training set, that will be j, and we have created means here whole code is not there, so cost can be a kind of list, and there we are appending all the loss functions which we have calculated. Now we are calculating the gradient. So in gradient means we are calculating the errors in the form of the gradient. Gradient means the derivative of the cost function or the loss function. Okay, so gradient means we are calculating, generally it is on the loss function, and then we are subtracted it with the previous loss function, and then we are calculating the error, and we are checking if the error is reducing or not. Next is theta. Theta is means weight. Also weights are adjusted based on these values. So this is the process to implement the cost function in the Python. So if you are having any doubt, then you can ask.
No doubt, Tulsi.
Okay, thank you then.